Dr. Lin is the research director for the automated publishing program in SP Labs. The team focuses on researches in multimedia analysis, image processing, and the composition technologies for search and organization of multimedia content, web-based multimedia services, and personalized publishing. Please let's welcome Dr. Lin to give us a
I'd like to thank CASPA for organizing this symposium. It's a great forum for people to share the information about the industrial trends, and we've seen several very great presentations in the last several speakers talking about the semiconductor industry and what are the technology trends. So what I'm going to talk about is what are the applications that will be running in this semiconductor chips and the machines, and particularly talk a little bit about multimedia understanding and the applications we have been building on the cloud platform and also for mobile applications. So first of all, let's see a little bit about what's happening in the content world. So here, what we see is that the content growth in social networks is really the key drivers in the past few years. So if you look at the Facebook users, there has been very, very significant growth in the last few years. And so if we think about the time that people spend on email, which is this blue line here, and the time people spend on social networks, it's growing very, very rapidly. So, so here is another view of the time that's spent, and so Facebook.com is this yellow line here, and the time horizon is essentially the past 3 or 4 years or so. And what you see is that the people used to spend a lot of time on Google, MSN, and Yahoo. So that's followed by this gray line here. And what you see is that the time spent on the search engines is really decreasing. Search engines and also content portals is really decreasing. And what you see, the blue one, is the time spent people spend on YouTube. And that's really growing very fast. And even growing faster is the time spent on Facebook. And so today, if you look at how much time people spend on Facebook versus some of the other things, it's already larger than Google and the Yahoo combined. So the other thing that's really interesting to see is the mobility. So 1960s is people spent the computing is done on mainframe. So there's only 1 million plus units in the world, and it's gradually moved to mini computer in the 70s and 80s, to PCs in the 90s, to desktop internet. So that's the current decade, and the next decade is going to be about mobile internet. So it's expected to have 10 billion units accessing the internet from mobile devices. So if we take a look at smartphone shipments, it's really growing very fast, and then we look at the application. What are the things that people do on smartphones? And a lot of it is through web pages. So if we look at, what are the kind of things people read from smartphone, accessing the internet, a lot of it is about news, maps, email, weather, and so on. So one of the interesting things is that today people don't do a lot of social networking on mobile phones yet, but that's expected to grow really fast. So if you look at the growth rate, it's really very significant. So so if we look at the content, what you see is that the content has a lot of different things, music, video, photos, apps, documents, shopping, and so it ranges all the way from user-generated content, professional content, and it's all really moving to mobile devices, and it's moving to cloud. So, so mobile devices is the access point for accessing those contents in the cloud. So, so as you know, HP is really one of the largest companies in the world about printing. And if we look at imaging and the printing implications, there's a lot of digitization and content growth that's going to drive the page growth. So today, there's a 56 trillion pages that will be printed in 2012. And 10% currently is printed digitally. But the trend is definitely toward digital printed pages. So 20+ billion pages are shifting to digital. And so why is this the case? The case is because people really want personalized information. People want relevant information. And so really the digital printing is the only way that people can supply the personalized and the information in digital form. If you look at what's printed, a lot of what's printed today, millions and millions of copies are printed. So those are not very personal. Those are really kind of printed for mass market. And so what's really going to drive the digital printing is going to be the personalization. People want to receive relevant information, and so those have to be in digital forms. So, so how does multimedia and content understanding play into this? What we really see is that the content source can be coming from different places. It can be coming from documents, web pages, images, and video. And there's a lot of technologies on understanding multimedia content and being able to compose multimedia content and allow paper and the digital interaction. And these are the things that are really driving the rendered output that's really, really personal. So, so if you look at the devices and the web services ecosystem, what you see is that the devices are all connected now. So even the printers these days are connected, and the printers, the new printers, are all connected to the web, and they have a email address. So what that means is that you can now email a file to your printer from your mobile phones, and those can be very easily printed. And so a lot of content clearly flows among these devices. So for example, images captured by mobile phones. And a lot of this content can flow to connected devices, such as what we are showing here at home or at retail. And it can also flow into web services, like for example, Facebook or Flickr or Snapfish. And so what are the challenges? So now I'm going to really narrow down a little bit to talk about more about personal media. And because there's a lot of very unique challenges about personal media. So personal media is the photos and the videos that people take from digital cameras or from mobile phones. And so right now, it's already more than 50% of the photos that's taken by any devices is coming from phones. So phone, in the future, smartphones is going to play a very, very important role in terms of photo and video capture. I don't know if people follow the amount of photos that's uploaded to Facebook each month. So is there any guess as to how many photos are uploaded to Facebook every month?
100 million.
Billion.
100 million.
100 million? 10 million? It's 3 billion. So people use Facebook to do a lot of the sharing with friends and the family. And so if you think about it, it's every few months, Facebook is adding more photos and the whole photos on the Flickr. So what are the user challenges in personal media? People capture a lot of this media. People do a lot of sharing of this media. However, they really don't have a lot of time to organize and tag them. And so what are the ways to really understand what's in the personal media so that some of the more manual tasks, such as tagging, can be done automatically? So one of the research challenge is to really understand from personal media what's in there. So who's in there? How many people are in the images? How many images have a particular person, which is a slightly different problem. How can I find all images with a particular person? Or what is this photos about? Is this travel? Is this birthday? Are there any pets in the photo collection? What kind of emotion does this picture carry? Is that something that express happiness, express anger? So these are all very important questions. And if you think about the ability for machines to understand natural languages, it's gone a very, very far away from 20 years ago. But if you look at how people can understand what's in the images, people really still have a very hard time understanding what kind of object is in the images. So there's a lot of research to do in the next couple of decades on this important problem. Another very interesting research challenge is how do you use images in communication? So some of the very interesting things people can do today is, like, for example, create photo products, like, for example, photo books, photo mugs, and so on. And in the future, we will see that more and more this kind of technologies will be used not just for personal enjoyment, but also for business communication. Like, for example, how do you really do marketing in social media? So what we have seen is that the content understanding is really important for improved photo and browsing and discovery. And so I'm going to share some of the research results that my team has been working on, and to give you a flavor about what some of the new capabilities are in terms of multimedia understanding. And then I'm going to talk about an example of creating a multimedia application and then have it run both as a web service and as a Facebook application and as a mobile application. So, so the first thing I'm going to talk about is the face clustering. So if you have a large photo collection, it's very, very hard to find all the photos with a particular person, and it's even harder to find photos of people taking photos together. So the technology we developed is can sort through the photos automatically, and then once it's sorted, it's showing up here. And it not only finds all the photos with a particular person, but also it maps out the relationship. And what it means is that you can find all the photos of several people appearing together. And so what this means is that in the future, there's a lot of opportunities to mapping out social relationship between people based on the way they appear in the photo together. And from a technology standpoint, it's enabled by a number of technologies. One of the technology is the face clustering that I mentioned. Another one is demographic classification. So by looking at the facial features, one can figure out whether someone is adult or a senior or a child, and also the gender. Now, if you have a lot of photo collections and you can figure this kind of thing out, then essentially what it enables is you to do is to figure out the family relationship. And so, what is a nuclear family? Who are the grandparents, and who are the children, and then what are the relatives and the friends? So it turns out the nuclear family, of course, in any photo collection appears in the photo collection most often, and they also appear in the photo collections often together, and then the grandparents, you can figure out whether they are on the paternal side or maternal side by looking at the appearance of the grandparents, the co-occurrence with their children, because they often appear in the photos together with their own children more and less with the in-laws. And so this is a very interesting technology to really mapping out the family relationship. And then another similar technology is you can figure out is mapping the social relationship. So people take a lot of photos with different groups of people at different occasions. So sometimes it's with the family, sometimes it's with friends, sometimes it's with coworkers, and even with friends, sometimes it's their kids' birthday party or school events or soccer team events. These are all really with different groups of people. So by looking at the collection, one can actually figure out all these social clusters. And another one is we're interested in is event classification. So is a possibility to figure out how you can, for example, find all your Christmas photos automatically. So, so there's a lot of cues, like for example, the time. So Christmas obviously occurs at the end of December, but sometimes the timestamp can be wrong in the digital camera. So if you didn't set it correctly, so if you didn't set it correctly, then you can. So what we developed is a feature extraction algorithm that can figure out what are the features of our Christmas trees, and really from that classify whether the photo is a Christmas tree event or not. Another one is a representative photo. So if you think about a lot of photo collections, because the way people take pictures with digital cameras, the clicks becomes free. So people used to be very, very careful at taking pictures, but now they take many pictures of the same occasion. So if you look at the photo collection, often it's really boring because a lot of the photos are related and the multiple shots are taken. So, so what we did is we used a number of seeing technologies, like for example, figure out using faces and also image features to figure out what are the near duplicate pictures. And so why is this important? If we can figure this out, then what we can do is really go through the image collection and then be able to figure out how do you tell a story from this collection. So what are the most important photos, what are the most important events, and who are the most important people in this collection. So here's an example result where there are multiple pictures are taken, and we can figure out these are all related, so we can pick the best one. So, so I'm going to talk a little bit about how these technologies can be used together to create some stories. And how do you represent that in a photo book format? So if you think about photo book authoring, there's a lot of things that you need to do. So for example, you need to figure out whether you want to create a big book or a small book. You need to figure out what are the themes you want to include in this book. You need to figure out what are the photos you want to select, how big it is, how to position it, which photos go on which page. And so this is actually a lot of very complicated tasks. And so a lot of software have been written to figure out how to automate some of this. And what we developed is a web service that really can use a lot of the multimedia understanding technologies to reduce the time that people will spend. And in the extreme, what we want to be able to do is to completely automate the creation process. So, so one of the technologies we developed is called Magic Photo Book. And so by looking at the photo in the collection, we can automatically select them. We can figure out the background and how to scale it. So essentially, the goal is that we want to be able to allow people to reflow the content very easily. So if someone decided that they want to have a portrait instead of a landscape, then they don't have to go back completely into the redesign of the photo book. And just kind of give you some kind of idea about the market. This is a very new market, but it's growing quite rapidly. So it's been growing more than in the double digits in the last few years. And the reason is because really this empowers people, ordinary people, to author books that's really highly relevant and highly personal. So so what we really want to be able to do is not just look at the algorithms, but also figure out how do we deploy this kind of algorithms in a cloud service or web service environment, and then being able to do it from different places, like for example, mobile devices such as iPad. And so in order to do that, what we did is we not only developed the set of algorithms to really understand the multimedia content, but also developed the web service that put the content with the ability to handle the content in the cloud storage, and then being able to scale it, and then being able to figure out the user interface and user flow. So, so we deploy a lot of backend servers and a database to handle this task. And the cloud service is online. It's called autophotobook.com, and we're very close to getting our next version out. And so essentially, people can upload photos and then create a photo book very automatically. And the new version will have connections to, for example, Facebook and Flickr, so that it can pull photos from Facebook and the Flickr account in addition to Snapfish, so that it makes very easy to do it. And so I'd like to share with you some of the considerations in terms of thinking about how do we do it in different environments. For the cloud service, clearly the content is in the cloud, so you move the content to the cloud, and then all the back-end computation. So for example, how to select photos and how to organize them is in the cloud. So what happens when you want to, for example, put it as a photo book app? Well, if you want to do a Facebook app, you still need to handle a lot of the server-side processing, like for example, the selection, the grouping, and the layout in your server. And then essentially, you can have the user interface in the Facebook so that people can actually use the Facebook photos and then create the book inside the Facebook. And so we did this near the end of last year. And so if you go onto Facebook, you will see a auto photo book app in Facebook that will allow you to put your Facebook album photos in a Facebook album together, and then create a photo book from it. Now then the question is, what about mobile phones? And so for mobile phones, there's again a lot of considerations. A lot of consideration is about what are the things we need to put into the client versus what are the things we need to put on the server. So what we did is we put a lot of the very heavy interactive elements into the client so that it's very fast. And we put some of the servers to do more complicated processing. And we have a HP photo book app, and it's in the App Store. So very similar to what Dr. Wang said about being able to reuse the IP. Here, it's very important to reuse the technology for different platforms. So I want to really wrap up and say computer vision algorithms is still really in its infancy. People really don't understand a lot about what's in the images or what's in the video as much as they could. So there's going to be a lot of challenges and a lot of research progress that's going to be made in the coming decades. But what we kind of really try to do is, we know that the machines are not at 100% accuracy today. And so what are some of the user interface and user interaction models that we can do to compensate for that? And I shared with you an application that we have built, and a lot of those multimedia understanding tasks are really hidden from the user. And so what people see is really a very automated workflow, very easy to use, and a lot of the hard computation is happening in the back end that's really hidden from you.